Okay, so on this video, I want to get you guys comfortable with using the instructions that you have right here in front of you, right? We're going to be solving 3x3 systems. How do we do that? Step one, we're going to select two of the three original equations, okay? So let me highlight this. It's already in bold. I want to use two of the three original equations, and what I want to do is modify them to get a variable to cancel. Okay, so I want to pick two equations, and I need to pick a variable to cancel, all right? And when I do that, that's going to produce a new equation number one that we call new equation number one. So anyways, let's read that first step, and let's apply that first step. I want to go to my 3x3 system, a system that has three equations with three variables. I'm going to pick two out of the three, and I'm going to pick a variable to cancel. So which two equations would you like to use? The first and the second, second and the third, first and the third, and on top of that, which variable do you want to cancel? You want to cancel out x's, you want to cancel out y's, you want to cancel out z's? Anybody?
First and third.
You want to do the first and the third? What would you want to cancel though if we're using first and third, which is totally fine? You guys, or how about this? Start with the letters. Do you guys want to cancel out x's, y's, or z's?
Y's.
Y's? Okay, if you want to cancel out y's, which two equations would you use?
Either the first or the second, the first and second, or the
First.
second and third.
First and second, or I would go for first or third, right? Because to cancel out this negative 2y with this y, all I have to do is multiply the top one by 2. Does that make sense? Okay, so let's do that. Let's cancel out y's just because you told me to, right? Now, if you would have said let's cancel out z's, we could do that. If you would have said let's cancel out x's, we could do that. Again, step one is to pick two equations and get a variable to cancel. So we are picking the first equation and the second equation, and we're going to get those y's to cancel by multiplying that first equation by positive 2. Okay? So you're going to have to write really small, and you're going to have to be very neat when you write. And I recommend drawing arrows. Okay? So 2 times 3 is 6. We have an x. 2 times 1 is 2 with the y, and 2 times negative 2 is negative 4 with the z, and 2 times 10 is 20. Again, I just multiplied 2 by each and every term in this equation, giving me this new red equation up here. And again, write small, write neat, and be precise, right? Okay, so now we're going to, second equation, we're not going to do anything to it, because we already have a negative 2y, and we modified the first one so we could cancel that 2y with our negative 2y down here. So I'm just going to draw an arrow. I'm going to rewrite it right there. That is a positive 6x. That is a negative 2y. That is a plus z. That is a negative 2. All I did was rewrite it. Okay? And now we're able to combine that modified equation that we did, the first one, with the second one, and cancel out the y's. Again, you guys told me to cancel out y's. That's the only reason why we're canceling out y's. If it were up to me, I probably would have canceled out z's, but it's all the same difference, right? As long as you pick two equations and get a variable to cancel. We got the y's to cancel. Let's see what we have left over. 6 plus 6 is 12 with an x. Negative 4 plus 1, that's a negative 3 with the z. And 20, take away 2, equals 18. And what we have here, guys, is a new equation that only has two variables. And that's exactly what we want. Let's actually box this in. And let's label this new equation number 1. And ladies and gentlemen, that is step one of this huge process, okay? And again, the goal here is for you guys to get comfortable with the instructions. Step one on the instructions, it was pick two of the three. We picked that one and this one. And we modified it to get a variable to cancel. The y's canceled. And we got this new equation number 1. That's why I did it in blue, and we even labeled it new equation number 1. Let's move on to step 2. It says go back to the original. Use the one equation you have not used. Which one have we not used? The bottom one. That's right. So we got to use that bottom one. No matter what, we have to use that bottom one. That's what a system is, using all the equations of whatever you have in that system. So we got to use the bottom one. But what's the goal here? We want to combine it with any other equation, of course modifying them, to get that same variable to cancel. So right here the y's canceled. We want to use this third one, but we need the y's to cancel. Okay? So I'm using this third one, but I need the y to cancel. The same exact variable that canceled on our step 1, we need that y to cancel also, right? So how am I going to get this 4y to disappear?
We
Multiply.
by 3 and top 1 by 4? Wait.
Yeah, well, it depends how, like, we could, if for this y to cancel, again, we want y's, yeah, for this y to cancel, because we want y's to cancel, we'd have to multiply this whole equation by 2. That would give us a negative 4y, right? Or we could multiply the top equation by negative 4. That way it would cancel with this 4y. Does that make sense? So what would you guys like to do? Multiply the top one, multiply the top one by negative 4, or the middle one by positive 2?
The middle one.
Middle one by positive 2. That sounds like a good deal. And again, to not confuse you guys, you might want to just rewrite the bottom equation. We need to use that third one. So you might want to rewrite it right here without doing anything to it. Plus 4y plus 3z equaling 7. And we said that we're going to take the middle one, put in parentheses, and we're going to multiply it by 2. So as I'm drawing my arrow this way, I'm going to put multiply by 2. Okay? And these are just notes for me. In case I make a mistake, I could go back and look at how I got to the equation that I have. So again, I'm taking this one, I put in parentheses, I drew an arrow, and I put a little note to myself. I'm going to multiply it by 2. So 6 times 2 is 12. We're talking about x's. Negative 2 times 2 is negative 4. We're talking about y's. 1 times 2 is 2, and we're talking about z's. And the last number here, negative 2 times 2 is equal to negative 4. Are you with me? Okay? So now I'm able to combine those two lines. What two lines? The third one that we haven't used and the middle one that we modified by 2. And what happens is that the y's eliminate, and that's the goal for second step, to eliminate the same variables as what we did in step 1. So because we eliminated y's over here, I need to eliminate y's right here. If I would have eliminated z's up here, I need to eliminate z's down here. Anyways, I think you guys get the idea. What is our new equation number 2? It's 13x, y's are gone, plus 5z equals 3. Might as well box this in, and we're going to call this new equation number 2. New equation number 2. And that was barely step 2. So let's just review what we did on step 2 right here. It said, go back to the original, use the one equation you have not used. That was this one, right? And of course we modified it, but the goal was to get the same variable to cancel, as you did in step 1. So that's why up here we canceled out y's, right here we cancel out y's. And at the end of doing step 2, you're going to get new equation number 2. And that's exactly what we got down here in blue. That's why I labeled it new equation number 2. Now we're able to move on to step 3. Step 3 says create a new 2x2 system. What does that mean? Take this new equation 1 and this new equation 2 and write them together, and that'll be your new 2x2 system that you could solve using linear combinations method or elimination method that we learned last week. Does that make sense? So step 3 is to take this one and that one, create a new 2x2 system. So I'm going to zoom in. Here is my new 2x2 system over here. It is 12x minus 3z equals 18. And the other one is 13x plus 5z equals 3. Are you with me?
Yeah.
Okay. So now we could just kind of ignore what we've done so far and just focus in on this 2 by 2 system, kind of like what we did last week. Let's get either x's or z's to cancel. What do you think's easier, canceling out x's or z's? Z's for sure, right? I don't want to deal with 12 times 13. I'd rather deal with 3 times 5. So I know I could just change to a negative 15, positive 15, and then I'll be good. So let's begin. We're going to change this to a negative 15 up there by multiplying by 5. And we're going to change the bottom 5z to a negative, or to a 15, positive 15 by multiplying by 3. So again, very important that you write nice and neat, draw arrows wherever your new equations are going when you're modifying them. So up on top, 5 times 12 is 60, and we are talking about x's. And then we go 5 times negative 3, that's negative 15, and we are talking about z's. And then 5 times 18, that's 90, huh?
Yeah.
Okay, thank you. And yeah, a lot of opportunities for mistakes here. Be very careful. I recommend using a calculator. The bottom one, 3 times 13, that is 39 with an x. 3 times 5 is 15, positive 15 with the z. And then 3 times 3 is 9. And now that we modified that 2 by 2 system, we're going to combine them, cancel the z's, and this is really ugly. 99x equals, that kind of scares me, but over here 90 plus 9 is also 99. That makes me feel really good because x is now equal to what?
1.
That's right. So when you divide by 99, x equals 1, and that's awesome. Now keep in mind, we're solving our 2 by 2 system that we created from the original 3 by 3. So don't go back to the original. We're still on this new equation 1, new equation 2, new 2 by 2 system. So when I have one answer and I need the other, what do?
You plug it in.
Plug it in, right? So let's plug it in. Which one do you want to plug it into, the top one or the bottom one? It doesn't really matter. Bottom, sure. Let's do bottom. It says 13x, so 13 parenthesis plus 5z plus 5z equals 3 equals 3. Okay, so I just rewrote that bottom blue equation right here, and I put parentheses in place of x because I already know x is 1. So let's take that one and put it right in there. Let's do the math. 13 times 1 is 13 plus 5z equals 3. Let's just solve for z now. Subtract 13, subtract 13. We will end up with 5z equaling negative 10. Last step here would be to divide by 5, giving us a final answer, z equals negative 2. So we have found the answer or the answers to this 2 by 2 system that we created, right? But of course we want to solve the 3 by 3 system. So in reality we have 2 of the 3 answers that we need. So we've already used all 3 equations, so it doesn't matter which one we use now. We could use any of the 3 and plug in x, plug in z, then solve for your missing value y. Let me pause right here and let me reiterate the steps that we've done so far. Step 1, use 2 of the 3. We used the 2 yellow ones. We modified it. We got the y's to cancel. We got new equation number 2, or new equation number 1. I'm sorry. And then step 2, go back to the original, use the one you haven't used, that's this red one. Modify something to get the same variable to cancel. We got new equation number 2. We took these 2 new equations, put them together to create our new 2 by 2 system that we know how to solve, which we did solve, and we got these 2 answers. And now we're on step 4. Substitute your answers back into the original. It doesn't matter which one you use in the original. You have these 2 answers. Plug both of those answers in, and you'll be able to find your third answer. So which one do you like to use, the top, the middle, or the bottom of the original? Anybody? Bottom? Okay. It doesn't really matter. And this is the beauty of this section. There's like 100 different ways of solving these problems. You could do it like so many different steps. And as long as you're not doing it wrong, you'll get to the same answer as everybody else, right? So I'm going to use the bottom one. This is what I'm going to do. I'm going to cut it. And then I'm going to move it over here. over here next to our, next to our answers. Yeah, it takes a lot of space. So let's use, I just rewrote the bottom one, and I'm going to plug in 1 right here and -2 right in here. Okay? So let me work it out. Instead of x, I put a 1 plus 4y. We don't know what y is. That's what we're trying to solve. Plus 3z. And z, we already know z is -2. Equals 7. Equals 7. So let's simplify this and solve it. We know that 3 times -2 is -6. Let's bring down the 4y that's right in front, and also the plus 1 out here in the front, equals 7. Let's continue to combine like terms. Let's combine the 1 with the -6. That'll give us a -5. So our new equation reads 4y minus 5 equals 7. And we're almost done. Let's just add 5 here, add 5 over there. Our new equation will be 4y equals 12. And now our final step would be to get rid of that 4, get rid of the 4, and we get our final answer, y equals 3. So our answers, x equals 1, y equals 3, z equals -2. Ladies and gentlemen, that is an ordered triple, not an ordered pair, it's an ordered triple. So let's go back to the original, and let's write down our answer, let's say down here. As an ordered triple, the answer will be 1, 3, -2. And you're going to have to type it in like this on the assessment Friday, no spaces between your terms. And that is your answer right there. Now, just like before, when we had an answer to a system of equations, you could, if you wanted to verify and be 100% sure that you got the right answer, you could take this x value of 1 and plug it in. 3 times 1 is 3. 3 right there. That's going to be 3 plus 3 is 6. -2 right there. -2 times -2 is +4. 6 plus 4, it really does equal 10. Then you could go on to the next one. 6 times 1 is 6. 2 times 3 is 6. 6 take away 6 is 0. Put a -2 right there. -2 equals -2. That also works for the second one. And the third one, 1 right here, 3 right there. That's going to be 1 plus 12 because 4 times 3 is 12. That's 13. And then plus 3 times -2, that's -6. And if you have 13 plus -6, that will give you a +7. Now, I know that's a lot, and I know I did all that in my head, but you guys should be able to use a calculator and plug in those numbers and verify that it works for all 3 equations. That way you could be absolutely certain that you have the right answer for the entire 3x3 system, okay? Again, the video that I'm making here, it's just so you could get comfortable with the steps up here, okay? Once again, step 1, pick 2 of the 3. Those are the 2 yellow ones we picked. You could have picked different ones, but on this particular path that we took, we picked the first one and the second one, and we decided to get y's to cancel, even though you could have picked x's to cancel or z's, but we picked y's to cancel, and we got our new equation number 1. This right here is barely step 1. Moving on to step 2, go back to the one you haven't used. That's this red one right here. I rewrote it, and we took the middle one and modified it by multiplying it by 2 to get the same variable to cancel, thus giving us a new equation number 2 for step 2. So we have equation 1, equation 2, that's your first step. Your second step, your third step says create a new 2x2 system. You take both of these, put them together as a new 2x2 system. There it is, new 2x2 system. Solve this new 2x2 system, getting your 2 answers. And then, final step, take those answers, substitute them back into any one you want in the original, and you'll be able to find your third missing answer. And you write it as a 3 ordered triple. I hope that makes sense. Now, ladies and gentlemen, on the following 4 problems, you're probably not going to have enough space. You might want to rewrite these inside your notebook where you have like a whole page for each one of these. As you can see, it does take 10, 15, in this case 20 minutes to do that one problem because I wanted to really go through detailed the explanation of it. Now let me tell you, 2 of these, when you do these, 2 of these, you'll be able to get nice ordered triple answers, okay? But 2 of them are going to be special cases. Now what do I mean by special cases? Let's say I'm working on this right here, and let's say I was working on new equation number 2, and let's say I was trying to cancel out y's, But let's say x is canceled, y is canceled, and z is cancels, but the numbers don't. So you end up with 0 equals 3. What do you say? No solution. So whenever you end up with something impossible, like all the variables canceling and the numbers not canceling, you could just stop your work and just say no solution. Okay? All right? Now don't get confused with the numbers canceling. Like if you'd have like a 7 minus 7, it's okay to get 0 over here on this side. It's possible to get the number 0 as a number. But if you get something impossible where all of your letters cancel, like 0 equals 3, you could just stop and just say no solution and you're done. So those special cases are kind of nice because sometimes you don't have to do that much work. Now let's say you're trying to do any part of this, right? Any part of this. Maybe you're doing step 1, maybe you're doing step 2, and maybe you're doing the 2x2 system. And let's say the 2x2 system you're working on, you get to step 3, you're doing your 2x2 system, and let's say that everything cancels. The x's, the z's, the x's, the z's, and the numbers. Let's say you had an 18 and a negative 18. Everything cancels. Then you would say what? When it's 0 equals 0, when it's always true, what do you say? Infinitely many solutions, okay? So on these 4 problems, and this is your assignment for today, on these 4 problems, 2 of them are going to work out great. I mean, if you do it correctly, you're going to get 2 ordered triples, and you're going to get 1 that's no solution and 1 other one that's infinitely many solutions. And there is videos for this already explained on Google Classroom. I hope you guys understood the steps and you guys are able to work on these.